What are common kinematic diagrams used in mechanisms? Have you ever wondered how machines convert motion? Kinematic diagrams are key to understanding this process. They simplify complex mechanisms by focusing on how parts connect and move together. Instead of showing every detail, these diagrams use basic shapes to representing links and joints. This makes it easier to see how everything works without getting distracted by unnecessary details. Let's look at some common types of kinematic diagrams. First up is the slider crank mechanism diagram. This classic setup shows how a rotating crank turns into linear motion through a slider. You will often find this mechanism in engines and pumps. The diagram highlights the crank, connecting rod and slider as simple links connected by joints. Next, we have the 4-bar linkage diagram. This mechanism consists of for rigid links forming a loop with for joints. The kinematic diagram reduces these links to simple lines and the joints to points. This type of linkage is essential for transferring and transforming motion in various mechanical systems. Another interesting type is the double crank and double lever mechanisms. These are variations of the 4-bar chain. The double crank has two cranks rotating continuously, while the double lever uses levers to create specific motion paths. Their diagrams clearly show how links and joints are arranged to understand their motion. In automotive applications, the steering mechanism diagram, like the Ackermann steering, is crucial. It illustrates how links and joints allow wheels to steer correctly. The fixed ground links and moving links are represented to clarify the steering geometry. In robotics, kinematic diagrams are used for robot manipulators, such as the PUMA robot. These diagrams simplify complex structures into links and joints, making it easier to analyze motion and control. They often show revolute and prismatic joints, detailing the sequence of links from the base to the end effector. Key elements in all kinematic diagrams include the frame or ground link, which serves as the fixed reference part of the mechanism. Links are represented by simple geometric shapes, while joints allow for relative motion. These can include pins, sliders, and other types of joints. Kinematic diagrams are essential in mechanical engineering. They help analyze degrees of freedom and motion paths, making it easier to design mechanisms. By visualizing complex assemblies in a clear way, engineers can study motion without getting bogged down by physical details. These diagrams are widely used in machine design, automotive engineering, and robotics. They are foundational tools in teaching kinematics and mechanism design, providing a clear framework for understanding how machines move.